So this video is about LeCroy LW420 AWG repair. This is a fairly expensive instrument at the time it was made. They are hard to come by now, and most of them don't work on eBay, or the used ones are pretty expensive if they are working. Anyway, I bought this on eBay on July of 2020. It was not working. At that time it was claimed it was working by the seller, but anyway, sat abandoned until late 2021. I hadn't had time to look at it. There were lots of issues, as I discovered along the way when I started to debug the instrument. This is one of my early repairs actually, and I'm making a video right now, even though it's more than a year now. I started work on it in early January of 2022. Many of the details of the work at that time was not recorded, and now I just reconstructed some of the slides and videos which I had taken of parts of the work I had done and put it together. So the first thing I discovered once I got this thing opened up was that the power supplies were not coming up. At least the negative rail voltages were not showing up on the board. And so I took apart all the power supplies, tested them. It turned out the positive was okay, the positive rail voltages, but the negative were gone. So then I started to work on that, got that fixed, and once I got that, the instrument would at least turn on, and it would come up to a stage where it could partially boot up the BIOS part of it. And of course the HD hard disk wouldn't come up, so basically nothing worked. The instrument was basically dependent on the hard disk coming up. So once I got that done, the hardware was done, the next step was really to fix the hard disk image, to clone it back into an SD card, and I got that done using Clonezilla, and that took several months until I figured out all the ways to get it done. It was required some help online, some help from some friends and so on. Anyway, the instrument is now functional, and it's actually a very good addition to the bench. It's got amazing waveforms and programmability and so on. Goes up to 100 megahertz in terms of the sine wave outputs it can put out. So in this section, I'll talk a little bit about the power supply. The main heart of the power supply is the controller chip, the PWM controller, and I think this was made by SGS Thomson and probably now by TI as well. And so this is used in a lot of these switch mode power supplies, and we'll get into that description and also some of the repair aspects of that supply next. So this is the block diagram, or actually circuit diagram, of the power supplies that are used in the LeCroy LW420. There are two of these. I'm just showing you the one of them, which is similar to what this circuit looks like. It consists of this input AC that's coming in to this bridge rectifier, whose output is smoothed and produces a current that basically charges this large capacitor initially before any of the circuit starts to work. Incidentally, this circuit is called offline flyback switch regulator. Offline refers to the fact that the AC is connected to this on this side of the transformer, and once this reaches a certain voltage, about 15 to 16 volts, this controller wakes up and basically will start to at the same time there is current flowing into this MOSFET, which then charges, basically provides a voltage that develops across this current sense resistor, which is sensed by this on this terminal number 3. Once it reaches a certain value, this MOSFET is turned off, at which point this inductor develops a reverse kickback voltage, which then drives current into the output through this secondary transformer winding. Once this turns off, then the cycle starts all over again, and basically this secondary winding on this side here will start to charge also this capacitor over here, C4, which then starts to provide current into into this, through these two diodes back into this capacitor and this network to basically keep the controller going. So at that point the startup circuit using R2 is not required anymore, and it basically is self-sustaining once after many cycles that this capacitor is charged up. The frequency of oscillation inside this controller is set by these two components over here, R6, C6, and the frequency is basically 0.55, it's not 0.5, it's 0.55 RC, and that works out to, in this particular case, to about 38 kilohertz, which is well above the audio frequency range. The other thing that's important here is there's some filtering of the kickback of the spikes that are generated by this turning off. That's filtered by this RC network that goes back into the iSense. There is some protection, over voltage protection, and so in terms of clamping this node to a reasonable value if this voltage goes too high, to prevent this from breaking down. Same over here on this side, the drain side, towards the positive supply. The secondary side is basically just simple diode rectifier that is charging inductive LC filter network, which smooths out voltage to produce 5 volts. And on this the secondary on this bottom one is basically a plus and minus 12 volt output. Usually the 12 volt is going to be a little bit lower current. Usually the 5 volt in these types of power supplies is a much higher current, maybe 3 to 4 amps typically. So as far as the LeCroy is concerned, there are two of these supplies, as I mentioned. The one generating all the positive voltages, the plus 5, plus 12. I believe there are two of them, that's all. And then there was a plus 15 which was generated differently, not on this, not by this power supply anyway. Then there was a second power supply which generated 3 voltages, plus 5, actually minus 5, minus 12 and minus 2. So the minus 2 was a weird one there, but it had all of them, the 3 winding, the 3 outputs as shown here. They were of course different currents and so on, capability, but overall the architecture looked very, very similar to what this particular circuit looks like. There were 2 MOSFETs here, I think because of the higher power overall. And the failure was, there was a failure on the minus 2 volt supply where one of these diodes was had broken down, had shorted through. And the other problem was the MOSFETs were also damaged. So I think the problem was some of the, there was some breakdown caused by, I think, over voltage, reverse breakdown, and especially on this device. So basically I made sure that these diodes were okay, protection diodes. So once I fixed this negative power supply, the whole instrument started to work and basically was able to boot up normally, but except that the hard disk wasn't working, or it had the software wasn't booting up. So the instrument was, for all practical purposes, dead. I mean, this is a PC-based instrument. Once the PC wakes up, it actually loads the firmware, whatever, to run the instrument, and that part, of course, wasn't coming up. So that was a much longer process to get that going. Had to figure that out through cloning the hard disk contents, and that basically was a learning experience for me. Anyway, I won't go into that in this particular video. This mostly concerns the hardware part of it, which I fixed. Here's the switch mode power supply for the LeCroy LW420 that I repaired. This has the negative output voltages minus 12, minus 5 and minus 2 volts. As you can see on the right side, there are 3 sets of wires that come out, pairs of wires that come out for these supplies. The failure in this particular supply were these 2 FETs, which were the 2SK904s, which I had to replace. There was also one of the rectifier diodes on the primary side that is shown over here also had to be replaced. The rest of the components, including the capacitors, were all fine. I checked the full wave bridge rectifier, the high voltage caps, and those seem to be okay. I did add extra protection for a snubbing RC network for this particular diode, which had blown on one side and had no protection. So I think that improvement hopefully will prevent further failure of this particular supply. So that's it for this one. I'm going to put it back and then test the rest of the system. Had one more supply to fix, which I will show next. This shows the board that sits on top of the two SMPS supplies in the LeCroy, which are the so-called low voltage supplies, DC supplies. This board combines those various outputs, brings it to the top of the supply module, and then distributes it to the rest of the machine. On the top over there, the bunch of wires you see go down to the main motherboard, which is not the actual AWG part of it, but the main controller part of it that includes a lot of digital chips and so on. To the left you can see the 4 wires that go into the hard disk and the floppy drive. The yellow is the 12 volt plus 12 volts, and the red is the plus 5 volts. There's also a 15 volt output right here, the third pin, and a negative 2 volt over here. The 15 volt is actually generated using this chip and another LM317, I believe, which is, you can barely see that over here. This chip had failed, and it's basically a switch capacitor chip which actually uses as a doubler. So the plus 12 volts comes in on this main part of on the top of the board, and it is then doubled and sent into this LM317 linear regulator, which then creates a 15 volt output out of the 24 volt or 23 volts roughly doubled output from the 12 volt supply. To the right, as I mentioned, these are going to the main motherboard, and there are a bunch of pins you can see here which I've desoldered, and these which go to the bottom of the AWG part of the machine. So these are all different voltages from plus 12, minus 12, plus 5, minus 5, minus 2, and then the 15 volts which I talked about. This is the main fuse over here, and there's also a supervisory chip, I believe, for the 5 volts, this one over here. So this is pretty comprehensive power supply for this AWG machine for LW420. In addition, there is also high voltage generator for the CRT, which is actually controlled by this part of the chip over here, of the board over here, and I didn't actually touch that. It seems to be okay. So here's the final after assembly, the whole unit. You can see it took me a while to connect these wires from the supplies up to the main board, which is on top, and that board basically distributes the power into the rest of the machine. You can see that wires here on the top go down to the motherboard, which has all the digital stuff, the programming and so on, and the one here actually goes down to the AWG unit, which is below. You can see the connections down there onto the motherboard, and soldering was done underneath this thing, which is a bit of a pain, but I managed to get it done, and I'm going to now power it on and see what happens. So here's my isolation power supply with the Variac. Currently it's reading 118 volts or so, and it's in got a current limit set at about 40 watts. So if it pulls more, it's basically a short circuit. It'll probably light up all the bulbs, and I'll let it probably shut down my unit. So I'm going to turn on the unit now and see what happens. So it's not enough to drive the unit with the power on, but it's at least not short circuited. So I'm going to basically bypass the the current limit and see what happens. So there you go, and it's now fully powered on with no protection on the current limit side. It's drawing 175 watts and 118 volts. The total AC current into this unit is 2 amps or so. That includes all the overhead that is inside this unit. So now we'll go back and see what happens to the AWG. So here's the AWG right now. It's running some beeps. So it's been a minute or so and it's still the hard drive is hunting. I used to get a screen earlier which said I need to load the firmware. There you go, and it's actually come up with that screen. So basically you have a functional unit as far as the hardware is concerned, but I need to load the firmware or the program into the hard disk so it can boot completely. And maybe I'll try that next, just to go and load the image file onto a SD card or some similar modern drive that I can use to see if this machine can actually work.